Good morning, students. Today we'll discuss your Demorgans theorem. We'll discuss the Demorgans theorem. In the last class, we have been simplified the expressions using Boolean theorems. There are 9 theorems. So now we can also simplify the theorems using Demorgans law. And using a Demorgans law, we can derive with the universal gates using basic gates. This is an advantage of your Demorgans theorem. Demorgans theorem. There are 2 Demorgans theorem here. The first one is x plus y whole bar equal to x complement into y complement. This is the first theorem. Second theorem, x into y whole complement equal to x complement plus y complement. These 2 theorems we can prove LHS equal to RHS using 3 different methods. You know that. That is, you are using algebraic method, using truth table method, and using perfect induction method. Truth table method we have already been solved in the truth table examples, and your perfect induction will do it in the later sessions. So now it is an important 5 marks question. Prove using algebraic method. Prove using algebraic method. This is an expression of your theorem. What is a statement? It looks like your NOR output. X plus y whole bar is equal to individual complement of 2 variables product. Individual complement of 2 variables product. Then this is equal to a NAND gate. That NAND gate is equal to 2 individual variables sum. 2 individual variables complementation sum. Complementation sum. How we can write the statement for this? Sum of 2 variables complementation. Sum of 2 variables complementation is equal to individual complement of 2 variables product. 2 variables product. 2 variables, sum of 2 variables complementation is equal to product of 2 variables complementation. That is your first statement. What is the second statement? Product of 2 variables complementation is equal to sum of 2 individual variables complementation. Sum of 2 individual variables complementation. That is your statement of your Demorgans theorem. Then whatever we have been defined in the statement, that we'll write it in the truth table. That we will write it in the truth table that we have already been discussed. And also we'll try to write the circuit diagram, like digital circuit diagram, using this expression. Here 2 inputs are there, x and y. That input sum of 2 variables complementation is equal to 2 individual variables complementation with product. Here you will get x complement y complement, x complement into y complement. This is your first statement. What is the second statement? 2 variables product two variables product, complementation, two variables product complementation is equal to sum of two variables complementation. Two variables complementation. What operation we are doing here? Sum operation. Two variables sum. This is your logic circuit diagram for LHS part and RHS part. Your LHS can also be written with the NOR gate. This can also be written with your NAND gate. This can also be written as your NAND gate. This is your circuit diagram of your two theorems. Then we'll move for the proof. Proof using algebraic method. We are proving the theorem using algebraic method. Here the theorem, both the theorems, either a first theorem or second theorem. We are proving this theorem using complementary law. Using complementary law. What are the complementary law? X plus x complement equal to 1. Sum of variable and its same complementation variable is equal to 1. Logical variable added with its complementation is equal to output 1. A logical variable product with its complementation is equal to output 0. Is equal to output 0. Here, instead of taking a x, we are assuming a variable p. A variable p. For the first theorem, p is x plus y. For the second theorem, p is x into y. This you need to remember and you should not interchange. How you can remember easily? Here the plus term is there, then you should assume the place of p what? X plus y. Here the dot is there, hence in the place of p what we should assume? X into y. X into y. We need to write this one according to the complementary law. P plus p complement is equal to 1. Is equal to 1. So, in the place of p, what I can write? X plus y plus as it is. X plus y in the place of p. P contains what? Complementation. Hence, write the complementation. That should be equal to 1. This is your first statement for the first theorem. What is the second statement? Your second statement is p into p complement is equal to 0. In the place of p, x plus y, same x plus y. Here plus was there, hence the plus. Here dot was there. What I can write? Dot x plus y. Here p complementation is there, hence it is a complementation, that is equal to 0. These two parts we need to prove for Demorgans theorem in algebraic method. This is for first theorem. Come to your second theorem, first part. P plus p complement is equal to 1. Same. The statement is same, but here in the place of p, here x plus y, here x into y. Plus will be as it is. X into y, p has a complementation. So the complementation, this is your first part. What is the second part? P into P complement is equal to 0. In the place of P, x into y dot will be as it is, x into y whole complement, because P has a complementation, that is equal to 0. That is equal to 0. This we need to prove for second theorem. This should be equal to 1 when we solve according to our algebraic method. We should get the output as 1 and this should get the output as 0. According to the first theorem, I should take P plus P complement equal to 1 with the assumption P value is x plus y. In the second theorem, P value is x into y. Second theorem has a dot operation, hence the assumption also dot. The first theorem contains the plus operation, hence the assumption of the P variable x plus y. X plus y. This is concept we require to prove algebraically both the theorems. Okay. Did you understood? Here, these two theorems are proved with which law? Complementary law. What are the complementary law? X plus x complement equal to 1. X into x complement equal to 0. Here, instead of taking a x, I have taken the variable as P as assumption. P, I am taking the value x plus y because the operation we are doing plus here. So, in the place of P, what I can write? X plus y. Here, how you got the x plus y complement? Here, P as x plus y. P has a complement, so completely it is a complement. Similarly, write for P into P complement is equal to 0. Here plus, here it is dot. Here in the second theorem, P we are assuming the value x into y. X into y. In the place of P, what we can take? In the place of P, we can take x into y. Plus will be as it is, x into y. Here P has a complement, hence it is a complement. P into P complement is equal to 0. So in the place of P, x into y. X into y. This dot will be as it is, x into y whole complement is equal to 0. By using these two assumptions, we need to prove both theorem number 1 and theorem number 2 in Demorgans theorem. Both the theorems we are proved with the which law? Complementary law. Using a complementary law, we are going to prove the theorems with how many parts? 2 parts. One for 1 and one for 0. Okay. First, today we will discuss the first theorem. In the next class, we will discuss the second theorem. So, this we can prove with which law? Prove using complementary law. Prove using complementary law. What are the complementary law? X plus x complement equal to 1 and x into x complement is equal to 0. Let assume P equal to x plus y. P equal to x plus y. P, x, y. All are logical variables. All are logical variables. So what is the first part? Let prove first part. Let prove first part. What is the first part? P plus P complement is equal to 1. Is equal to 1. According to that, how we can write this one? X plus y plus x plus y whole complement is equal to 1. This is your first part. This is your first part. Let I am taking only LHS part in the first one. First part, only LHS part. What is the LHS part? X plus y plus x plus y whole complement is equal to 1. We need to prove. We'll prove. Did you notice this? It is the same. Yes. According to Demorgans theorem, x plus y complement can be written as x complement into y complement. The same theorem we are using. Which theorem? Demorgans theorem. THM means theorem. According to Demorgans theorem, I can replace this one x complement into y complement. X complement into y complement. The remaining terms will be as it is. X plus y plus. Do you remember your x plus y can be written as y plus x according to your commutative law? Commutative law. According to commutative law, I can replace these two. So I am taking x complement into y complement as a first term, and continuation the first term here in the second term. That means this have been copied over here, this have been copied over here. Now apply distributive law for completely. Distributive law. Apply now distributive law. X into complete term, y into complete term. This is your first term, this is your second term. What you will get? X complement plus x plus y. X complement plus x plus y, entire term as it is. This dot gets out. Y complement plus x plus y. X plus y. Now I am rearranging the terms. Rearrange the terms. Term variables. Rearrange the term variables in the each. So this I am rearranging in the form of x plus x complement plus y into x plus y complement. You know that x plus x complement can be written as 1. Then these two can be replaced as 1 plus y into x plus these two terms gets replaced by 1. According to your 1's property, x plus 1 can be written as 1. Then these two gets replaced with 1 into 1. 1 into 1. 1 into 1 according to your AND property. According to your AND property, this can be written as 1. Did you got your RHS part? Yes, this is now your RHS part. We got LHS equal to RHS, that is x plus y plus x plus y whole complement can be written as 1. Then this is equal to this. This is equal to this. We have proved only first part. We have proved only first part. That is your p plus p complement is equal to 1. Now we need to prove second part. What is the second part? In the second part, your plus was replaced with dot, that is equal to 0. Only here gets changed. Please notice over here. And this we need to prove it as 0. Then take a first part, LHS part. Apply your Demorgans theorem. What you will get? There is no commutative law now. Apply your Demorgans theorem. What you will get? X plus y into x complement into y complement. Apply your distributive law. What you will get? X dot x complement dot y. This plus is out. Y into x complement into y bar. Now we have applied what? Distributive law. We have applied distributive law. Rearrange and copy the terms. What you will get? There is no change over here. X into x complement into y plus x complement into y complement. X into x complement can be written as 0. So this you will get as 0 into y plus x complement x into x complement into y complement. Here I have missed the y complement. Please copy down. So here it is complement. Here you will get complement. X complement into y complement can be replaced as 0. Any value multiplied by 0, what you will get? 0. 0 plus 0. This entire term gets replaced with 0. 0 plus 0 equal to 0. According to your OR postulates, you will get this one as 0. Did you got your LHS is equal to RHS? X plus y into x plus y whole complement can be written as 0. Your RHS we got. So take a part. Assume P equal to x plus y. P into P complement can be written as 0. X plus y whole complement is according to your Demorgans theorem can be replaced as x complement into y complement. Apply your distributive law. No need to apply your commutative law for the second part. Why? Because it was there according to your distributive law. Hence, no need to apply your commutative law. Directly we can go for distributive law. Rearrange the terms. When we apply the distributive law, what you will get? X into x complement into y complement. This entire term will be copied as it is. This plus will becomes out y into x complement into y complement. Rearrange the terms such that we will reach to one of the theorem. X into x complement can be written as 0 into y complement. X complement into y complement can be written as 0. Any value multiplied with 0, you will get the result as 0. 0 plus 0 according to our OR postulates, it is 0. It is your 0. You have been proved your second part. That is P into P complement can be written as 0. This theorem we have proved using which law? Complementary law. Okay. We'll continue in the second theorem.